One of the things we see embedded in our everyday lives that we take for granted is this concept of percent change, of things increasing by a percent or decreasing by a percent. And we're going to look at how to find the percent of change of something when it increases or decreases from one period to the next. So this is a picture of the front page of the New York Stock Exchange website. I took that screenshot and I blocked out the percents, and we're going to find out what that percent is. A little bit of information on the data. The symbol represents the company people are trading on, so GE is, I'm assuming, General Electric, and I'm not sure what the rest of these are, but they're all companies. The volume is how many stocks are bought or sold over a certain period of time. Could be a day, could be a month, I'm not sure, but it's basically how much is trading hands. The last price is the price after we've gone up by 33 cents, or we've gone down by $1.15, or gone up by 10 cents, or down by 18 cents, or down by $1.19. So this is the price currently after this change. The change is how much the price decreased or increased since the last time the data was taken. So we're going to find the percent that we changed from the last price, not the last price, but the price before this to this price. So here's the formula. Percent of change is the amount of change of the original amount. That's going to be the basis for which you need to plug in numbers. Sometimes you have the information right in front of you, and sometimes all you have to do is just type it in, divide, and turn it into a percent. But sometimes you don't have all the information. We know the amount of change because that is this value right here. It increased or decreased by this amount from the last pay period to now. But we don't know the original amount because this represents the price after the change. The original amount was the amount before the change. So let's figure out how to find the original amount. And that's just simply going backwards. If this was 3 cents more than the original price, then we're going to take 33 cents away from it. If this is $1.15 less than the original price, then we're going to add $1.15 to it. If this is 10 cents more than the original price, then we're going to subtract 10 from it. If this is 18 cents more than the original price, we're going to add 18 to it. And if this is $1.19 less than the original price, we're going to add $1.19 to it. When we do that, we're going to find that this is how we would plug in our information. 2975 is 3008 minus that much, which is 1.01097. When I move the decimal place twice to turn it into a percent, and then round, it's 1.11%. The next one, 115 over 740, because that original price was 115 more than this, so 625 plus 115 is 740. Divide those, 0.155, move it over, 15.54% decrease because it had gone down. And you can calculate the same for the rest of them. 10 cents, 1768, which means you subtracted 10 from this, and that was the price before. That's a 0.56% increase, so it went up barely. This one's a 4.22% decrease and a 3.68% decrease. So you always want to make sure that you actually have the number that's the amount of change, and you actually have the original amount. We need to find the original amount sometimes, or we need to find the amount of change sometimes. We don't have all the information. We need to find it. So it looks like we did pretty good. Our data lines up pretty well. Like unit rates, percents are a great way to compare things. So a stock market has lots of different companies of lots of different sizes. You can compare them all and see how they're doing similar to one another by percents, because percents are based on 100. This means no matter how big or how small the company is, we can determine the health of the company by basing them on 100, and that is by making them into percents. So take a minute to figure out this activity. There's 4 or 5 companies, and each one increases by a certain amount. I want to find the percent change, or the percent increase in each case. You can't do it by eye. You're going to have to calculate it. And in order to do that, you need to know the amount of change over the original amount. Do we know the amount of change? Are either of these numbers the amount of change? If you look at them, that's what this changes to, and that's what it changes from, but it doesn't show how much it took to change it from this to this. What was the leap from 4527 to 4824? And that's what we need to find. So we don't know the amount of change. Do we know the original amount? It originally had stocks 4527. Yes. So that's 4527 in the first problem, and 1028 in the second, 250.18 in the third, so on and so forth. Find the amount of change by taking the new price and subtracting it from the original price, and then divide them and turn them into percents. Figure out which one costs or is growing the most. Once you've done that, you're going to try this problem. What is the percent increase from 3817 to 4545? Possible answers are 84% increase, 119% increase, 19% increase, or 16% increase. You're on page 207, numbers 1 through 12, for more problems of finding percent increase and decrease. Okay. What I want you to do is I want you to look up this video on measurement error, and it's called World Around Us Object. Go online, look through it. It's a great tool to help understand and recognize measurement error and why it's important. And then there's a couple of questions that you need to answer afterwards. If the sphere was the size of the Earth, how far apart was the highest mountain and lowest valley? And after the second weighing of the kilogram bell, the difference between other weights was the weight of a fingerprint. Why is that tiny measurement error such a bad thing? But we're going to move on. So with the greatest possible error, take a measurement unit, doesn't matter what you use. Measure the length from your elbow to your wrist, and then write that down. Think about what tool you used. What unit did you measure your length in? Write that unit next to the length measurement. What is the smallest unit of measurement on the tool we used? In most rulers, it's either 1/2 of an inch or 1/16 of an inch, or you could have measured in centimeters, and I think they go down to millimeters sometimes. So write down the smallest measurement. Question is, could we be more precise? Can you use smaller units to be more exact on your length, or would you have to guesstimate to be more accurate? Greatest possible error is recognize any tool that you have in the world could be just a little bit off, just like the kilogram bell was a little off. So to compensate, we give a range that the measurement might be off. This is called the greatest possible error. So take that smallest unit measurement that you found on your device and cut it in half. That is the range above and below your measurement that the true length may be in. So you measured a certain distance from your elbow to your wrist. Take the smallest measurement, if it's 1/16 of an inch, cut it in half, which would be 1/32 of an inch. Or if it's 1/2 of an inch, then cut it into 1/4 of an inch. If it's a centimeter, cut it in 1/2 of a centimeter. If it's a millimeter, cut it in 1/2 a millimeter. Find the greatest possible error of your measurement. So find that range from above to below and see where your real measurement of your elbow to your wrist may be. Okay, try this problem also after you're done with that. James measured the width of the shed he's building and it came out as 12 1/4 feet. The tool he measured with can measure 1/4 feet at the smallest. So basically take a foot and it goes into quarters on his measurement tool. What is his greatest possible error? Is it 1/2 of a foot, 1/2 of an inch, 1/8 of a foot, or 1/8 of an inch? Try to figure that out and then unpause when you're done. Page 207, 15 through 18 will help you work on problems with greatest possible error. There's also the concept of greatest possible error when you're looking at measurement. If you measure a room and find the length is 13 feet and the width is 7 feet, what are the maximum and minimum possible areas? Well, we know that based on our measurement, it's 91 square feet. But since we're only given that the measurement is in whole feet, we have to assume that the greatest possible area is a half of a foot, or 0.5 feet. So the minimum possible area is found by taking each of our dimensions, our width and our length, and subtracting a half of a foot from it, and then multiplying those. That's the bottom range. The maximum possible area is taking those and adding a half of a foot to each. And so our max area is 101.25. So the range is about 20 feet of difference. So try this one. The length of a rectangular house is 12 yards and the width is 7 yards. What are the minimum and maximum possible areas of the rectangular house if we measure with a yardstick that only measures in full yards? Those are our possible answers. Look through them after you're done and unpause to go forward. Page 207, 19 through 24 for more problem area possible error measurements.